Hey everyone, I hope that you're all fine given this situation. My name is Rebecca and I'm going to talk today a little bit about privacy preserving methods and how to build secure projects. My name is Rebecca. I'm from Recife, Brazil. It's a place near the ocean. I graduated in computer engineer in the University of Pernambuco. I'm very proud to have been a student there. I'm a football fan and I work as a software engineer at Vinta Software. We are kind of a team of experts from Brazil and we are based in Brazil and we help clients evolve products from backend to frontend to design and infrastructure, pretty much everything you need. Okay, I'm gonna talk today a little bit about security and privacy, and I envy a lot of people that don't have any type of concern about this. I wish I was one of those people, but unfortunately, I'm not, and I'm very concerned about these topics. And this is pretty much we have like a lot of big companies, and they really like to test what they can do with our data. And I just bring to you just a few examples of a few misuses of privacy breaches that were caused by big companies. My favorite one is this one from fitness trackers that they were able to show to everyone a location of a secret U.S. military base. So that's quite interesting. And we have like governments now, and they're trying to regulate to ensure that the people like have more privacy while using like applications and systems. But I don't know what you think about that. But I don't know if any good came out of this. I bring to you two examples of a guy who just used an app to track like his rides on his bike, and that made him a suspect of a robbery. And this is an example from my hometown where they are using like mobile phones to monitor social isolation. I don't know how you feel about that. You may feel that the government has the right to do this to citizens, but it's a debate that we need to have as a society. And the consequences of all this like debates and discussion is that first scientists they don't have enough data to build like new models because basically all the most important data is in the hands of big companies. And I think the worst thing is that we don't feel safe. We think that we are being watched all the time and it's like we can't do anything to solve this. And I would like in this talk to show you that there's a few things that we can do, and I'll show you a few situations when we can hurt the privacy of users, but I'm gonna show you ways on how you can protect the privacy of the users. And I'm gonna show you some simple examples, and then we're gonna go to more like complex situations. So I would like to start with very simple situations like you want to collect and release data that contains answers to sensitive questions. So you have like a group of people have a lot of questions that you want to ask them, and you wanted to put these results on a database and then just like get statistics out of this. Uh, when I say sensitive questions, I really mean sensitive questions. Like assume that I'm an athlete and I'm gonna ask like questions like have you ever used illicit drugs to enhance performance? We have two options. We have like a clean athlete that didn't use drugs, and we have an athlete that may have used drugs or used drugs. And assuming that these people answer the question honestly, we will have like a database and we'll be able to do like queries on this data set. But there's a problem with that, and it's kind of if I allow people to just get statistics from my data set, it doesn't mean that I'm protecting privacy. Just by not allowing them to get individuals' names doesn't mean that I have privacy. In this example, you can see that with two questions, I can know for sure what is if Jane used or did not use illicit drugs. And that's why statistics are not safe. The name of the attack that we just simulated by asking different questions is called differential attacks. And we can do many more types of attacks that just try to find the individual information that identifies the users. So we must be careful when like allowing people to do queries over large data sets. But let's continue on this situation. I still want to do this, and I still want to do this protecting privacy. How should I do it? We still have the same question, and we still have two options. The difference is that now I'm gonna just do something at data collection time. So I'll give the user, the athlete, a coin, and I'll say, flip the coin, don't let me see the result. If the coin is heads, so you will answer yes, you have used illicit drugs. If the coin is tails, you're gonna say answer honestly. And this will make the clean athlete and the dope athlete both answer a yes under certain conditions. So we are giving like the people in the research a type of plausible deniability of the presence of if they use or did not use illicit drugs. The idea of this technique is called randomization, and it's a technique used a lot in the 60s. And the idea is that people could not answer questions honestly without being like held accountable, without being like suffer some kind of prejudice at that time. So they developed this mechanism to give people the plausible deniability by the coin flip, and it works very good if you have many examples, and it still allows you to recover the underlying statistics. So you can get the mean, you can get the percentage of users that use one or who did not use, and every other information, statistical information that you would like to collect. But let's put this type of sensitive questions aside. You don't care pretty much about that. You wanna just collect and release data because it's important for you, because you have a partner, you have to share this information with your partner, or you have like a third party that provides you a service and you want to just get the result, or you want to share for some research example. Like the applications are many. And what could happen is the first thing that you will do will be like remove names and remove social security numbers. But there's a few things that you need to think other than this. There's a few attributes that they are called like quasi-identifiers, and they are by itself not unique. Many people may have them. But the idea is that when you put these attributes together, they can give enough information to identify a person. Here, for example, we have 87% of the US population can be uniquely identifiable by zip code, gender, and date of birth. So with these three information, we can get we can identify one person in a database. And this gets a bit more tricky when we join database. So we can get, with this three information, we can get all the information of a person's life, which is, I think, a little bit critical. One way to solve this is, here we have quasi-identifiers as age and country, and we have a sensitive attribute. They want to hide this attribute. We don't want to let people know the salary of these other people. And what we will do is we will pair the quasi-identifiers and the country into general groups. So we'll make people fit in groups, and we have people, more than one people in one group, so we cannot point to the people directly in a database. And the technique that does that is called key anonymity. The idea is that you can create groups with at least k people that share the same quasi-identifiers. So you cannot just point one person by looking at the table. And we can do this by using generalization. That is, we will just get an attribute and we will change the granularity of the information. Or we can do this by suppressing information, by removing information that we think that leaks too much information. There's still a problem that is linkage attacks, that we can some other future data may appear and then boom, you have a privacy breach. There was an issue like this with the Netflix subscribers. You can see it was a context that they made, I think a while ago. I don't remember exactly the date, but I have a very similar example that is quite recent. I'm going to talk about it just a little bit. In Brazil, we have a big company called Vivo. and they just released a data set that was anonymized, and they sell this data set to like the government and everything, and this data set became public, and then some journalists were able to identify like 2 or 3 persons in the data set by linking the data that was public with data of concerts or something like that. There's a link here, and you can see exactly how they did it. But the idea is that even though you think that you anonymize your data, you can just like be at some point, some other data may appear, and people may be able to draw connections between the data. That's why you have to be extremely careful when releasing data. There's a few refinements of key anonymity in order to like protect against these types of attack, but they are all not perfect. And I would like to just point that you always have this trade-off between privacy versus utility, so usability against privacy. So you cannot fully anonymize data and remain useful. So this will always be like a risk standing on your shoulder when you are releasing data sets in this manner. I also have a few more examples of applications that use key anonymity. One example is they have a BIPOL solution. I will leave the links here so you can check how it happens and how is the implementation. And I also have a simple implementation, you can check that later. Another situation that I would like to talk is you don't care much about releasing data, you have a data set, but you want to make generalizations over a population. How could you do that? Sometimes it's important, you want to know if you should launch product A, product B, or you want to know like where your clients are liking the most. You want to make like general consults over your data set. How should you do that in a private manner? Because you remember that we discussed that we cannot allow people to do many statistics on the data because we can still leak private information. And the idea is like how can we make like consults on a data sets private? And there's a lot of people that talk about definitions of privacy, and there's a lot of people that say a lot of different things. But one definition that I think that suits well our situation here is this one, that privacy is pretty much an agreement between a data holder and a data subject, and the agreement is pretty much that the owner of the data will not be affected by allowing the data to be used. And the critical part is no matter what other studies, data sets, or information sources are available. So this is kind of critical because before you remember that we were concerned about other information appearing and people being able to do like links between the information, and this definition kind of says this is not important because we will have something that will protect you against this other information that may appear. In the context of a database, what this means. The idea is that you are doing queries over your data set, and if you remove one person from a data set, the result of your query will not change, then the privacy of the person is fully protected. So an attacker is not able to know if he's doing queries on a data set with your data or without your data. So this gives you a kind of plausible deniability of your presence in the database as well. The name of technique, the state this is called financial privacy. It's a technique from 2006 and is a formal definition of privacy. And I'll really soon show you the equation. And the idea is that you can learn about the teachings and the underlying information on the database without learning about the actions of individual people in a database. And it does that by adding some kind of noise in the query to protect from differentiation attacks. So adding the noise is kind of randomness or like a random mechanism is kind of the critical part here. I'm gonna show you the formula now. Bear with me with this here. The idea is that we have a term on the left, and this term just means that we have one data set and we have a protocol that does queries in a data set, and these queries just have private results. And the term on the right is that I also have a data set, but it's only different by one. And I have another protocol that does queries that gives me privacy. The idea is that these two terms they differ by e raised to the epsilon power, which is a very small number. So when you're doing queries of both data sets, they are like pretty much the same. And this epsilon variable is extremely critical here because it allows us to like tune the amount of privacy that we want for a project. So we have a way to measure the privacy loss that we have when doing queries, and we have a way to define a privacy budget, which is like critical for like many projects. So I may define that above a certain level, I'm leaking too much privacy and will not be safe for me to allow people to do consults on this database. And another interesting thing about this technique is that we have like many open source implementations, and they are like pretty much amazing. I will like recommend you to check that later. Uh, a nice application of this technique is most use emoji. It was developed by Apple, and apparently we have a smiley and crying face as the most used emoji. And in second place is heart emoji. And these techniques they will be like your best friends when you have like regular applications, and they will help you assure privacy to users. But I would like to remind you that if you are using data from like European citizens or you're bound by a few regulation, there's still a few more things that you need to comply with. So you need to like encrypt data and do all of the safeguards that the regulation like ask you to do. So still need to give it a look on the regulation. Don't These techniques will help you, but you're still gonna need to like go one step further in order to like comply with the regulation. Okay. Another situation that I would like to talk about is like if you wanna build prediction models. We talk a little bit about like regular business models, but we have like new business models that like rely on like prediction models and artificial intelligence and machine learning. How can you do that while like assuring users privacy? One example of application, just so we like get into the mood, is when you how's the name? You type something on your keyboard and it tries to predict where you're typing. So this is an example of a prediction application that is like on mobile phones and that we use pretty much every day. And mobile phones get they kind of have all our life in it. So how can we assure privacy in this context? So the idea is that if you're a big company and you want to just put machine learning in people's phones, what you do is that you will build one model and you then share this model with many clients. And your clients they will use this model and they will interact with this model and they will change and customize this model locally. And at some point they will have like a new model, and when you have like a good amount of good models from different people, you send these models to the server, and the server will then aggregate these models without ever seeing the customer's information, and you generate a new model and send back to the users. This technique is called federated learning, and the idea is that mobile phones they can like uh, collaboratively build prediction models while keeping the training data on device. So you never ever send customers' data to the cloud. And this was a technique developed by Google, if I'm not mistaken. And they say a lot of things. They say that it gives you smarter models, lower latency, and a lot of good things on that. There's a few tools that you can do this on Python, and they're all amazing tools. I have tested a few of them, and I have left you link with some implementation here so that you can check. Just a simple example of how you can use federated learning and send like code to clients, and they will execute and then send the results back to you. Uh, okay, there's a problem, and if you were like some person in the area, you may have seen the problem, and is that you can still infer private information by the diff between the models. So the service knows like the model is sent to you and it knows the model you receive. So you still can like infer some type of private behavior from the user and get some type of private information. So this technique by itself does not assure you privacy, but it's a good way for you to start, and it should be used with other techniques in order to assure privacy. But you still want to update your model with users' data, and users' data might be like many users, and it's a critical part for your business models to like having your data updated with data of a lot of people. And this is critical like for hospitals because they can't just legally hand over the information to other hospitals, or the same thing for intelligence agents, but how still they can like cooperate without like sharing private information. This is a critical point. And the way that we can do this is that we create a protocol that allow users to conceal private information, usually in a encrypted manner, and you can make computations over many sources of data without revealing the individual results. And I have an example of how this would work. Let's assume that I have a system with 6 people here, and I want to know the average salary of this person. So I don't have a trusted third party to just give all the information, then this third party will return to me the result. I don't have that. And the way I would do that is I'll have the first person to just get his own salary and just add a big number. In this case, I'm kind of cryptographing the salary, and then I'll pass to the second person. This person will then add his own salary and they will pass to the third person, and everyone will add up the salary to the initial value, to the value that the previous person passed it, and the final number will then come back to the first person, and this person will then decrypt like the number by removing the big number that she added at the beginning, and then will then perform the operation that in this case is an average, and then we'll say the result to everyone. And the advantage of this technique is that everyone will know the average, but no one will be able to tell what was the salary of the previous person or the next person or anything like that. So the name of this technique is called secure multi-party computation, and it's amazing when you have multiple owners when you have multiple people building models together, and allows for individuals to share the control of the model without the need of a trusted third party. No party learns any other party's inputs, and that's critical. And the only thing that the people involved, they can like infer is what can be inferred from the output, and is usually used with other techniques. So this technique can be used jointly with federated learning to assure privacy in the processing of it's like updating machine learning models from mobile phones. And there's also like amazing tools for you to do that. I have left some examples here, and there's a small implementation here that you can check that later. Oh, sorry. Uh, the last thing in a situation that I would like to talk about is that sometimes you don't have multiple owners. You are the owner of the data, but you can't download your data and process on your machine, or you can't process in the cloud because it's not safe, or because you just sign a contract and you can't have other persons processing the data. How can you do that in a way that you still follow the law, you still follow the regulation, but you still get the results that you need? There's a technique that allows you to perform some types of computations on ciphertext, so in encrypted data, and you can obtain results in encrypted format, and these results can only be decrypted with the owner of the secret key. So it's good for the user because it just gives me the security that if I encrypt a file and I give to a third party, and this third party will perform some kind of processing, and this third party will not know the information that I'm sending him because it's encrypted, and the results that the third party sends me will not be like the third party will not understand the results because they will also be encrypted, and only me with the secret key will be able to decrypt it. This model is also good for the third party because let's assume that you have like a prediction model that is like amazing, top notch, and like very innovative, and you want to protect your data. So you would encrypt your model, and then you will be able, other people will be able to train and use the results of your model without ever seeing the inner behaviors of the model or stealing the secret sauce of your model. The name of this technique is called homomorphic encryption, and it's good when a model has a single owner because the idea is that data is never only encrypted outside the user's environment and allows computation on encryption data. And this is like the critical part because you can get encrypted results that only you, the owner of the secret key, is able to decrypt. And this technique is also, people say, right? I didn't verify, but it's secure against quantum computers. And we have a few open source implementations, and I think that this will be like the technique that will like gives us privacy or private processing to in data in the future. And I say that in the future because we're still a long way from like production use. Pretty much because data, this type of processing works best with integers, and initially it's still like pretty slow. So there's a few scaling issues. If you do with a small amount of data, might be okay, but if you have like a big amount of data, it may be very difficult for you to use this technique. So, a resume of what we have discussed today. We have talked about randomization to collect sensitive information, key anonymity to release dataset, but be careful with this. Differential privacy if you want to do aggregations and consults, pretty much to privacy data analysis. Uh, Federated learning and secure multi-party computation if you want to do like create prediction models and machine learning models using data from clients, and homomorphic encryption that allows you to make operations over encrypted data. And this technique may be like the way they'll solve privacy issues in the future, but not yet. There's a few other things that I wish I had the time to talk about, but I encourage you to like search for this and give it a look. Uh, to end this, I would like to leave you with a few takeaways. The first one is if you deal with data of European citizens, please get a lawyer and see if you're compliant or not, or what is the small things of the law that you need to comply with. Remember that data cannot be fully anonymized and remain useful. You always will need to think about this trade-off between privacy and usability. Queries of over large data sets are not protected, so remember that. And doing statistics also is not safe because you can like tweak the questions into getting private information. And remember linkage attacks. That is when people can get your released data set and join with another information, another public available information, and just infer information from these people. So uh, please check this when you are releasing data. It's very important. And that's it. Thank you. If you have any questions, please email me. Comments and feedbacks, please send it to me. And that's it. It was very nice to talk to you today.